So today we're going to put everything together. We've got translations that slide, reflections that flip, rotations that turn, and dilations that enlarge or reduce, or dilate. And so we're going to put it all together and get some practice with just kind of working through several of them in the same problem. So when we combine two or more transformations to get one single transformation, the result is called a combination. Or a composition, a composition. So a composition is when you have, so a composition, when you write a composition in English, you're putting several things together, several ideas together. So the same thing it goes here is this is a composition because we're putting several ideas or several movements together. So let's look. So the vertices of PQR are 2, 6. I'm going to graph this first one, but we don't have to graph. I just want you to see what it's going to look like. -4, 2. That's P, that's Q. And R is at -3, 3. -3, excuse me. Okay, so this is my original shape that I want to make these changes to, and I'm going to do multiple changes. Now, sometimes we'll ask you to break it into pieces, and then sometimes we won't. So P was at 2, 6, Q was at -4, 2, and R is at -3, 3. So the first thing that I want to do is I want to find the coordinates of the vertices after it is translated 4 units down. So that's the first thing I want to happen. And then I want it to be reflected in the y-axis. And so we're going to do two different things. So the first thing is we're going to apply this rule to 4 units down would be x and then y -4. Don't forget your rules have to have your x and your y in it. So we're going to take this entire triangle and we're going to shift everything down 4. So again, like I said, I'm going to show you in this one with the drawing, but you don't have to do it with a drawing. So 1, 2, 3, 4. 1, 2, 3, 4. There's my R prime, my Q prime, P 1, 2, 3, 4. There's my P prime. And so here is my new triangle with having been translated down 4. Oh, that didn't draw very well. Having been translated down 4. So now my new points. Now, you can also look -4, -4, -4, and you can just do it over here on the points. So 2, and then 6 minus 4 is 2. And look, your Q is at your P is at 2, 2 now. Your Q is at -4, -2, and your R is at -3, -7. The thing you have to be careful of, again, when you're translating is adding and subtracting those negative numbers. Okay, now let's look at, now I want to translate it, or I want to reflect in the y-axis. Remember, when we reflect in or across the y-axis, we're changing horizontally. Remember, moving your hand horizontally like you're flipping it across the y-axis. So we are trying to flip it across this y-axis. And so remember, when you do that, when you flip across the y-axis, your XY rule becomes, when you flip across the Y, the X value changes. So we're going to change our X values, but keep our Y values the same. So it would be -2, 2, +4, -2, and 3, -7. So what has happened is P flips from being on the right to being on the left. There's P double prime. It's been changed twice. Q is 1, 2, 3, 4 away. It will be 1, 2, 3, 4 away on the other side. Q double prime, and then R is 3 away, so it will be 3 away on the flip side. And so my new triangle that has been translated, it has been slid down and then flipped over, is now right there. And so that's your final answer, is that P double prime. So does the order of transformations matter in the way that's going to happen? So in this particular case, no, it wouldn't matter if you flipped it first and then translated it down. Sometimes it does matter, but in this particular case, no, it wouldn't. So we're going to do this one. We don't have to do this on the picture. You can always do it on the picture if you want, but we're just going to start here and we're going to follow the rules. So originally I'm at 2, 6. I just like to have them where I can get to them really easily. So I'm going to take a minute to just write this down real quick. -3, 3. So we're going to use our same points. This time I'm going to translate it. Remember, this is going to go to the left 3. And down none. And then I'm going to dilate by a factor of 2. about the origin. All of our dilations are about the origin, don't forget. So if I'm going to shift to the left 3, I'm going to subtract x minus 3. So my original x was 2. And if I subtract 3, then I'm going to be at negative 1, 6. If I subtract 3 from negative 4, I'm going to be at negative 7, 2. And if I subtract 3 from negative 3, I'm going to be at negative 6, 3. So there's my intermediate spot after I have translated. So after I've translated, now I want to dilate. So I'm going to take those points, right? So then I'm going to change from here to here. And I'm going to dilate by a factor of 2. Remember that that is your x and y become scaled versions of that. The scale factor by x and the scale factor times y. So my scale factor was 2, so it will be negative 1 times 2, which is negative 2, and 6 times 2, which is 12, negative 7 times 2, which is negative 14, and 2 times 2, which is 4, and negative 6 times 2, which is negative 12, and 3 times 2, which is 6. Everybody gets multiplied. You can't multiply just some. You can't do just width or just length. You have to do everything. If you do just one or the other, then your picture is going to be all stretched out and funny. Like when you go in a Word document, if you don't drag it from the corner, then your picture gets weird. That's what happens when you just multiply one or the other, but not both. So we have to be sure that we do both. Okay, so let's look at 3. So 3 is a reflection and then a rotation. So let's do first. Okay, we need to do them in this order just to be sure, to make sure that they don't matter. So I've got my M. Again, I'm going to write these down right here just so I have them handy for quick recall. So I want to reflect about the x-axis. Remember, when you reflect about the x-axis, you're moving your hand up and down. So your y value is what changes. So your xy becomes x negative y. Your y value changes because you're moving your hand up and down. And so we're going to change that y value. So the negative 2 and the 1 becomes a negative 1. And then we have our x stays the same and our y value changes. So that's where our new point is after that reflection. Now I need to rotate it. So I do need to rotate it from where it just left. So I need to change the M. So I do want to put my M prime. Remember, you don't have to actually draw this accurately. When you do a rotation, you can just do a quick, okay, M prime is in quadrant 3, N prime is in quadrant 4. So if I rotate 180 degrees about the origin, we always rotate about the origin in here. And so if I rotate about the origin 180 degrees, remember we switch for every 90 degrees and then we name it by the quadrant that it lands in. So M is going to be switched and then it's going to be the same. And so the order of my points is going to stay the same. And then I landed in quadrant 1 where it's positive, positive. So I can leave M as positive, positive. Then I've got N. N is going to go switch and then same. And so his ordered pair is going to be the same order, 3 and then 4. And it's in quadrant 2. And so you need to go in and name it according to the quadrant 2, which is negative, positive. So it's a negative 3, positive 4. So that's where your final answer is. It's at that M double prime and N double prime. So would you get the same result if you performed the rotation first? Probably so, but you need to always double check it. Sometimes it matters and sometimes it doesn't. If we rotated it first, let's just do a quick check. If we rotated it first, M started in quadrant 2, and so M was here, and N was in quadrant 1. So if I rotated 180 degrees after I reflected it, or if I rotated it and then reflected it, so if I rotated 180 degrees, then that would be 1, 2. So I would have ended up in quadrant 4 and then reflected it about the x-axis. That would have put me up into quadrant 1. So it wouldn't have mattered in this case. I still would have ended up with that positive, positive. Okay. And because I went twice. Now, a rotation of 90 degrees would make a difference maybe because you switch the order of the coordinates. Okay, and this last one, let's look at what we have. Pay attention so that I always hear a lot, I don't know which way to go. Remember, we've got our pre-image and our image, so we can look at the coordinates and see what is our pre-image and what is our image. And so what we have is that this yellow triangle right here, that is our pre-image. I can tell because of the way that it's labeled. And then this purple triangle is our intermediate. That was our first step. And then this blue triangle here is our final step. That is where we ended up. And I can tell because of the double primes right here. And then the single primes right here. So to get to that first location, that's a rotation. Think about, you can't flip it that way, right? It wouldn't maintain that orientation, so you can't translate it that way. That doesn't turn it on its side. The only thing that's going to turn it on its side like that is a rotation. So, and it's a rotation of 90 degrees because A went from quadrant 1 to quadrant 2. So it is a 90-degree rotation, 90-degree rotation. Okay, and then we need to look at our second piece. So then to go from quadrant 2 into quadrant 3. So pay attention to whether it got flipped over or whether it got slid down. To do that, you need to be sure that you look at the way that the orientation of your letters. So in the top one where it started, my new pre-image, A's on bottom, C's on top, and B's over here on the left. Well, if you look in your new one, A's on top and C's on bottom. So that has been reflected instead of being translated. So that is a reflection across the x-axis. Okay, so when you put several transformations together, you're like doing several problems all in one time. It is